Hi, welcome to my talk. Today I'm going to be discussing soil health opportunities for almond growers. My name is Dr. Karl Wyant and I work for Heliae Agriculture. There's a photo of me just so you know there's another human being on the other end of the monitor. Just a little bit about me. I finished up my PhD in soil science from Arizona State after working in a number of areas across the country in soil science, including the Arctic and Colorado rangelands. When I finished up my PhD at ASU, I took a job as an agronomist, particularly covering the area from Phoenix to San Diego with an ag retailer. And then I worked in the precision agriculture space as a manager until 2019. Last fall, I became the Vice President of Ag Science here at Heliae Agriculture, where I oversee the internal and external trials and also help out with the agronomy training behind our product line. One piece I'd like to talk about today is how almond trees need microbes. You have very large trees and very small microbes, and the key message here is that these soil microbial communities that are associated with the trees are critical for long-term growth and development. And that was some work that was recently published and work that we also corroborate with the data that I'm going to present over the course of my presentation. And just one thing before we dive into it, a quick review on what the different microbes do for your almond trees. So we can split the microbes into two groups, fungi and bacteria. The fungi help to increase that root surface in the mycorrhizae. They help with improving plant nutrient and water access. They can have an influence on soil structure through the actual white mycelium and hyphae that threads through the soil, and they can also help with improving plant tolerance to stress. On the other side are the bacteria, and these bacteria have been noted for their improvement in plant available nutrients, particularly phosphorus and potassium. One piece that they've also been noted for is helping to solubilize micronutrients such as iron and manganese and zinc. Bacteria can have an influence on soil structure, similar to the fungi, but a different mechanism. With the bacteria, it's not the threads moving through the soil like the hyphae have for the fungi. It's really this glue called EPS, or a polysaccharide, and that can help stick your soil particles back together. And I'll show you an example of that here later. And finally, just like the fungi, microbial communities, including bacteria, are noted for their improvement in plant stress regulation. I mentioned before that I work at Heliae Agriculture, and we have a revolutionary technology sourced from microalgae that can drive yield and quality by activating the soil microbes. And we do this by feeding the microbes. Our products are part carbohydrates, part lipids and proteins, so we can feed the soil ecosystem a diverse food source and drive that diversity below ground that you need, including fungi and bacteria. So to feed your almond microbiome, we have two products, Phycoterra, which is our conventional product, and our Phycoterra Organic. So same foodstuffs, same quality ingredients to feed your microbiome, but the two products can address both sides of the agricultural production models. So our food source allows you to put an emphasis on the biological component of your soil. And this complements what you're already doing on the physical management of soil with your tillage, disking, and other amendments with gypsum applications and sulfur to improve the physical structure of your soil. We also complement what you're already doing from a chemical standpoint, and this includes your chemical, your fertilizer programs that are going out and other management strategies. So we can take what you already have integrated into your production models, physical and chemical, and really emphasize that biological component because we provide that food source to feed the fungi and feed the bacteria that are in the soil. And this gets down to this concept called soil health. And soil health is a term that is used to describe the interaction between organisms and the environment. So it's that soil environment. So you have living things, how they interact, and how that soil health comes together to influence your almond crop. And one way to think about soil health in a much more condensed terms is just biological integrity. how full of life are your soils? And generally, the more living things, microbes, fungi, and bacteria included, the more biological integrity you have, the better that soil is for producing crops. And I'll show you some examples of what an improvement in soil health looks like and what an improvement in the biological integrity of a soil looks like, so you can integrate it into your future plans. So I mentioned that improvement, and here's an example of that. Here we have a farm soil, and we've asked those microbes to grow on these plates. And we have the control here on the left side of the screen, and we've asked those microbes to grow from a farm soil. And you can see not a whole lot of action here. You have one colony come in, and then pretty sporadic growth in the rest of the inoculation streaks. We added the food source, that microalgae that's in Phycoterra and Phycoterra organic, to the plates that are on the right side of the screen here, and you can see a very different response in terms of microbial abundance and diversity. Most of the inoculation marks filled in, and then if you take the coloration and shape as a marker of diversity, very different microbial community. Earlier I mentioned the EPS, the glue that holds soil together. That's what this plate is showing. Here is the glue. It kind of looks like an egg yolk, but that's EPS. When microbial communities, particularly bacteria, get large enough and healthy enough, they start to secrete these glues in mass, and you can start to see soil structural changes. But you need to have that biological integrity in the soil to support this type of activity. We've taken this test a step further, and we've gathered soils from many different farms. And here we have the soil properties lined out by pH and organic matter as seen on a soil test. And we also have the texture. And then we have the incubation time here just to show how long we can elevate that improved microbial community for. So we made these plates for the visual representation, the control on top and the Phycoterra plate on the bottom. And so on some of these acidic, sandy soils, we see a consistent increase in both of these examples with two different incubation times. We also took a look at some soils a little bit heavier, but really, a lot of organic matter, 3.7%. Here's another soil with 3.2%. Incubated them for 12 and 21 days, and what we see is a consistent elevation. And you can really see that. I'll just call your attention to this 15x increase. Here we have a pretty drastic change in the microbial community. You just eyeball that response control versus the Phycoterra plates. And then finally, we went and integrated some Western soils, low organic matter, higher pH, and saw a relative increase and received that, with 21 days incubation time. So if you think about your farm, all the different soil types, there's a fit for feeding those microbes, and Phycoterra provides a consistent response regardless of the soil type and texture. We took this approach to another level, and we started looking at, well, we know we have an impact on the microbes, the fungi and the bacteria. We know when we improve those populations, we get the glues, that's the EPS I showed, that egg yolk looking substance. We also get the nets that spread out through the soil from the fungi and tie particles together. So we asked the question, how do we influence soil structure? So that's what I'm showing on the screen here. Here's a number of different soils: silty clay, loam, sandy loam, fine sand, and across that soil texture triangle. And what we're showing is when we take the untreated soil, which I'm showing here on the far left of each panel, not a lot of structure there, not a lot of oxygen in this soil, if you think about it from a field perspective, hard to get water in there. What we did was we applied Phycoterra, stimulated the microbiome, got the glues, got the nets, and after 40 days, we were able to drive a very different change in soil structure. So unstructured mass on the untreated control, a lot more aggregates and agglomeration once we went after the actual living things that control this change in structure. That's the microbial community with their glues and nets. And we saw this across different textures. So here's silty clay loam, here's a loam soil. Even on some of the sandiest ground here, we went from beach sand here down in the bottom right panel activated the microbiome, got the glues, got the nets, and we're able to drive an increase in the aggregate size as shown in that test tube on the far right. So improving your microbiome and improving your soil structure comes with other benefits. And those benefits include an improvement in water holding capacity. When you have good soil structure, you can pull more water in from an irrigation or rainfall event and store it for later. At a much more microscopic level, you can take that water and store it around the particles and in the actual pore space itself. So what I'm showing here is a number of different soil textures. Sandy soils are on the right, middle textured soils are right in the middle, and then some of your sticky, silty, heavier soils are on the far left. And what I'm showing on the y-axis is the change in measured water holding capacity between the soils that receive Phycoterra and those untreated controls. So on sandy soil, we saw upwards towards 10% improvement in the water holding capacity. And that's just after 40 days because we went after that foundation, that microbial connection to soil structure, and here that microbial connection to the water holding capacity. So we're able to store more water in that soil because of the mechanism that actually controls it, and that starts with the microbes. In those middle textured soils, we saw an improvement of 4 to 6% in water holding capacity. And on the really heavy, sticky stuff, we actually improved soil structure enough that we actually got better drainage. And that's why we have a decrease here in water holding capacity. So that connection between microbes, soil structure, and water behavior, and storing that water in the soil as plant available soil moisture for later can't be understated. It's a strong connection. And here we show that connection from the microbes all the way through the water holding capacity. So your almond crops respond to this change in the growing environment below ground, and they respond to the improvement in the soil microbial community for those reasons I mentioned earlier, and also here to that physical, water relationship, and also to that improvement in soil structure. Good soil structures, they receive more water and can store it, as I'm showing on this screen, but they also, better oxygenation, easier for those roots to get around, and an overall improvement in the growing environment for the crop. So what we like to do with almonds is set up a program, and this closely matches your fertilizer programs in terms of timing. But what we like to do, and I'll show you research that supports this, is have a program and set it up on a regular feeding schedule so we can keep that microbial community going throughout the year and keep those benefits going for the soil, for the water improvement, water holding capacity, for the soil structure, and have your crop have that better and improved growing environment. So here's the soil structure laid out in the soil improvement program, and it starts in the fall after harvest is done. So right now is a great time to get Phycoterra or Phycoterra organic out, feed that microbiome, start that cascade of events, so you can start building it for the 2021 season. So we have a recommendation of 3 to 4 quarts an acre, and then we follow up in early spring, in late spring, and then moving into that late spring and early summer application. So pretty easy program. One piece that makes this even easier is that we have exceptional fertilizer compatibility. We can mix with just about anything you have going out, including UN32, your phosphates, calcium fertilizers, and for your organic growers, we have exceptional compatibility with a number of organic liquid products that are out there, including your fish emulsions and your corn steep liquors, among other things. So great compatibility, a great fit to what you're already doing, and a regularly prescribed program, as I'm showing here. So I'll show you some data that backs up this program next. And then what I'm going to do is walk you through different ages. And I have here the year, the leaf. So this is second leaf, very young organic almond trees near Atwater on some particularly sandy soil with very low organic matter. And what I'm showing here in the red box, I don't have yield data because of how young they are, but how we improved the growth of those early trees because we set up that chain of events. So we set up the microbes by feeding them, we set up the improvement in soil structure, set up that improvement in water holding capacity, and those young trees responded with a 30% average increase in trunk diameter over the year that we measured this. So that's the tree response, but what I want to showcase here is that soil response, just to set up this expectation that we are driving improvements in the field. Here's our measure of improved active carbon on our almond program. And active carbon is a way to quantify how much microbial food is in the system. We improved that by 34%. On the soil structure side, we improved the aggregate diameter. That's the little agglomerated piece of improved soil structure. We improved that by over 30%. And then we also improved soil protein, which is a measure of plant available nitrogen, by almost 20% by putting it on the program. So the crop response is down here, but really on those early establishment trials, really what you're looking at is that change in the soil growing environment, which I show plenty of data here. Here's 6-leaf almonds near Atwater on some pretty sandy soil with low organic matter. And this is our first year on the program. We just received in this data. And what we have here are 3 different programs. So we put out this application rate 4 times over the year following that program that I mentioned earlier. So if you add these up, this is a gallon total, 2 gallons total, and then 3 gallons total over that year. And what we see in the first year is a nice improvement in ROI. And what this ROI is saying, for every $1 you spend on the Phycoterra program, this is the dollar value you get back due to this consistent yield response across the different treatments. Moving into some 12th leaf almonds, same setup on the trials. And this is replicated third-party work. A nice yield ladder with the program and very consistent positive ROIs across the board on 12th leaf almonds near Sutter. I just want to point out the soil type change. This is a little higher quality soil, and we saw this nice response in the meat yield pounds per acres from this lower rate all the way up to the higher rate. Last but not least are the older ranches that are out there. This is 19th leaf almonds, and this is the second year of this program. This is near Merced. And what we were challenged was, hey, I've got an old ranch, I'm about to push it out. What can you do to improve my yields and help me avoid that? They didn't want to quite get the equipment ready to push this out. So we put it on a program, and this is a little bit different. It's a 4 gallon per acre program as opposed to that 3 gallon per acre program we usually recommend. And what we found was across 2 varieties, even on these older fields, Nonpareil and Carmel, really nice return on investment across the board, really consistent yield response. And that's because we rejuvenated that microbial community and started that cascade of events to help improve the soil health for even a 19th leaf almond orchard. Just to wrap this up, holistic soil management strategies benefit almond crops, in particular that microbial centric viewpoint, as I've showed in the last few slides, can have an improvement on your yield in the first year, and it really sets up that ranch to have those improvements throughout the age class of the trees, as I showed, from year 2 establishment all the way up to 19th leaf almonds. And we provide that microbial food source so that you can go after the biological components of your soil that are already living in the soil, that are already there, put them to work and get those benefits. And I showed throughout my talk this key connection between almond performance and soil microbes. Big tree on top, little guys in the soil, but they're intimately connected in all those ways that I've mentioned throughout the talk in terms of microbial biomass, glues and nets, soil structure, and water holding capacity. So I want to close. My last statement is feed the microbiome, put them to work. They're usually on the brink of starvation. If you feed them the right food source, that Phycoterra or Phycoterra organic, you can pull them out of dormancy and get them to work for you and to work for your soil and your crop. Thank you for your time and attention. If you would like to know more, please visit our website at www.phycoterra.com. Furthermore, you can reach out to our regional sales manager, John Collison. There's his phone number and his email, and we can provide you with some follow-up and answer any questions that you may have. Thank you for your time. Thank you for your attention. Have a nice day.